Hello class, today we'll be starting on chapter 5.1, linear equations in two variables. If you recall, when you solve an equation involving one variable, we would solve it this way, whereby we'll move the numbers over to one side and isolate the variable that we want, in this case x, on the other side, to solve for x. In an equation with one variable, you will have one unique solution for the value of x. In B, we'll see another example of an equation involving just one variable. Similarly, it will only derive at one answer for x. As such, we say that when there's an equation with just one variable, the equation will have a unique solution. Okay, now let's look at linear equations in two variables, x and y. When we have a linear equation in this form, we say that the equation has infinitely many solutions. So why is that so? If we look at the linear graph, the graph can extend infinitely towards the left or the right, which means that the values can go on forever and x is always related to y in a certain way. If we look at this example here, we are asked to rewrite 2x plus y equals to 5. We would want to express y on the left-hand side and the x terms on the right. So here we will have y equals to negative 2x plus 5. Do you remember what negative 2 stands for? Yes, negative 2 stands for the gradient. So in this case, when you have a negative gradient, the line will be downward sloping towards the right. And this number 5 here is the y-intercept. So the y-intercept is where the graph cuts the y-axis. Okay, now let's look at activity 1. We are given the equation x plus y equals to 8. And we are asked to complete the following table of solutions based on the given equation. So if we rewrite the equation x plus y, we will have x equals to 8 minus y when I bring my y over to the right hand side. So to find my missing box x here, I'll need to think, when y is equals to 1, what would my x be? So x will be equals to 8 minus 1, which is my y value, and hence it gives me 7. Similarly, to find the other two unknowns, we rewrite the equation. So y will be equals to 8 minus x. So when x is equals to 2, to find y, we will use 8 minus 2 and we obtain 6. Similarly, in the next box, we have 8 minus 4, which gives us 4. Okay, let us now draw this graph out based on this equation given here. So we're going to plot our points first. So our first point is 0 and 8. Always remember to read the x-axis first before the y-axis. Okay, next we have 2 and 6. So we have another dot here. Okay, next we'll have 4 and 4. And lastly, 7 and 1. So these are our 4 sets of coordinates that are given based on the table that we have just now. So to draw the graph, we simply join up the 4 points. Okay, let's look at the next part. Okay, reading from your graph, what is the value of k if 3, k is a solution of the equation x plus y equals to 8? So looking at the graph, when the x value is equals to 3, we will connect the dotted lines up to the graph and read the corresponding y value. So in this case, this y value, which is actually my k, is right in the middle of 4 and 6. Hence, my value of k is equals to 5. Let's look at part D. If 2 and 1/3, comma q is another solution of the equation, estimate the value of q from your graph. Notice that in this question, the question says estimate. It is not expecting you to get a very accurate answer, and we'll explain why later. Let's try and find 2 and 1/3 on the axis here, sorry. So if we look at this, it is not easy to draw exactly where 2 and 1/3 is. So I'm just going to estimate it. Alright, so my corresponding y value, or in this case q, will be approximately 5.6. Okay, so in part E, instead of using the graph, it is now asking us to use substitution to find the exact value of y when x is equals to 2 and 1/3. So if we substitute x equals 2 and 1/3 into the equation, we will find that y is equals to 8 minus 2 and 1/3, which would actually give us a value of 5 and 2/3. So let's look at part F. Can you read the exact value of q from your graph? Okay, as we know, this value here was estimated, whereas this value was calculated based on the equation. From the graph, we can actually not read the exact value. And why this is so is because it was really hard for us to clearly locate where 2 and 1/3 was just now. Hence, if your coordinates are decimals or fractions, you will not be able to read it accurately because there's a limitation of the scale of the two axes of the graph. Alright? So, if your coordinates are in decimals or fractions, you'll have difficulty reading an accurate answer from a linear graph. Let's look at activity 2. Okay, in this question, they want us to determine if the following ordered pairs are solutions of 2x plus 3y equals to 18. So, we will do so by substituting the x and y values into the given equation, 2x plus 3y. Okay, so if x is equals to 0, okay, remember for ordered pairs, we always read x before y. So this is x, 0 is x, and 6 is my y value. So 2 bracket 0 plus 3 bracket 6, okay, which means I'm actually multiplying here. This will give me 18. So if I compare this value with the given equation, which is 18 over here, I'll find that, yes, it fulfills this equation. Therefore, I would say that 0, 6 is a solution of 2x plus 3y equals to 18. Let's look at the next example. If you have the points 2, 5, similarly, by substituting x and y into the expression, I would get 2 times 2 plus 3 times 5, which would give me 19. So this is actually different from the equation that we want, which is 2x plus 3y equals to 18. Hence, we would say that the ordered pair 2, 5 is not a solution of the given equation 2x plus 3y equals to 18. So in later questions, to check if an ordered pair of coordinates is a solution of the given equation, we substitute the x and y values into the equation to see if it fulfills the equation.